This is the first example of how you can solve acceleration problems graphically. A car starts at rest and speeds up in the negative direction. After 4 seconds, its velocity was negative 12. So you always want to start by picturing the motion, and it's speeding up in the negative direction, so I'm going to sketch a motion map for myself. This is the initial time. The initial velocity, which we can write as v with a subscript I, is 0. Part A, sketch and annotate the position time, velocity time, and acceleration time graphs. So sketch some graphs, and then annotate means label anything that you know. So thinking about the velocity, it started at rest, and sometime later, after 4 seconds, it had a velocity of negative 12. So that's down here somewhere. And this is constant acceleration because that's the only kind we're studying. So this would be a straight diagonal line. The slope of this would be the acceleration. And the area would be the displacement of the object. The slope here is negative, so we know it had a negative acceleration. And based on this velocity becoming more negative, we know that this graph has to look something like this. We don't know where it started, so you could also draw your curve up here. Okay, so this is annotated with the final velocity, the initial velocity, other things that I know are going to be true. Part B, what is the acceleration? Acceleration is the slope of the velocity time graph. And if we look at the velocity time graph, we can see that the rise over the run, the rise is the change in velocity because the y-axis here is velocity, and the run, or the horizontal part, is the change in time. It's the time interval. So the slope would be the change in velocity over the change in time. Well, the change in velocity is negative 12, and the time interval was 4 seconds. So that gives us negative 3 meters per second per second. So the acceleration is negative 3. Part C. What is the displacement during the 4 seconds? Displacement is the area of the velocity time graph. And we have here a triangle, so that's going to be 1/2 the base times the height. The base of the triangle is the time interval. The height is the change in velocity. So it's 1/2 times 4 seconds times negative 12 meters per second. And we can see that the seconds cancel out, and that leaves us with units of meters. And this gives us negative 24 meters. Okay, and then we could label that on this graph. If this is 4 seconds, if it started at the origin, it would be at negative 24 meters at that time.